Now, previously in this unit, we were taking quadratics and solving them to find solutions, right? Now what we're going to tell you is, here are the roots or the solutions. Find the original quadratic formula or quadratic equation. So basically what we're doing here is working backwards. Before, we used a quadratic to find the solutions. Now you're given the solutions, find the quadratic. None of this is actually new to you. All of the processes that we're about to do, you have done before. Okay? So, let's make up a little example here. Let's say we're given two roots of x equals 7 maybe. Oh, that's black. That doesn't show up. X equals 7 and x equals 6. Now, if you remember, when we're solving a quadratic, you're solving, what is one of the ways to solve a quadratic? There we go. What's one of the ways? For what else? Besides the quadratic formula? Factoring. So right before the solutions, when you're factoring, what do you have? The factors, right? So when we're given the solutions, we have to find the factors for those solutions. Now, remember, factors are like this, 2 parentheses with x's inside and the number right next to the x. So right now, the number is on the other side of the equal sign. We need to get the number to be with the x. How do I do that? How do I get that 7 to be with the x? Very good. We subtract the 7 over. And we subtract the 6 over. So that's why here in our example it says x minus, because we're subtracting it over. So we have two factors here. One at x minus 7 and one at x minus 6. Now, from here, I know you don't have this f of x equals, but you can write it in. Oh, you do? Oh, okay, never mind. So, how would we take these two factors and then have the equation in standard form? What do you think we do here? Just like we just did with the i's. What is happening between these two? These are being multiplied, so we double distribute. We distribute the x to the x, and what do we get? X squared. Distribute the x to the negative 6, and what do we get? Distribute the negative 7 to the x, and what do we get? And distribute the negative 7 to the negative 6. And then negative 7 times negative 6, and what do you get? So, we combine our like terms, and what do we get? And we're done. And we're done. So that's how you take roots and find the equation. Now I know that the next step says solve for a. However, in on level, we're not going to ask you to do that. We're not going to ask you to solve for a. So you can cross that out. All right, let's try an example here. Now, on this example, instead of saying these are the roots, they expect you to be able to look at this graph and tell what the roots are. Yes, the roots here are 2 and 3. So we have one root at x equals 2 and another root at x equals 3. Seth, I can't tell. Are you talking to yourself, singing to yourself? Okay. So to me, I think that that sounds like you're talking to someone, and I realize that everyone around you isn't listening to you at all. And it looks like you're talking to yourself. It looks like you're an insane person. From here, that's what it looks like. All right. So, How do I then take these roots and eventually get to my quadratic? What's my next step? What did I say to do above? What was the next step? We take our roots and get the, starts with an F, factors. How do I, from these roots, find my factors? Subtract the numbers over to be with the x. So what are my two factors here? X minus 2 and wonderful. Now what do I do to get my equation? Yes, you double distribute, double rainbow. X times x is how much? X times negative 3 is how much? Negative 2 times x is? And negative 2 times negative 3? Wonderful. And our like terms are what here? So, my equation is x squared minus 5x plus 6. Now I just found this equation. Is this exactly as it should look if I'm trying to circle my final answer? No. What am I missing? You need to have the function or the y in front. So I'm going to put f of x is equal to get full credit. Now, if you had been in pre-AP, we would expect you to check to see if there is an a value. And the way that I told them to do this, remember, these are quadratics, so the x's are always what? The x's are always squared. So I go from one perfect point to another, and you do rise over run. It's actually run squared, because remember the x's are squared. So what's my rise here? Nope.
Yeah, you can't see the line.
Well, look up at the board. 4. Can you ask it? 1, 2, 3, 4. And what's my run? Oh, I see. Okay, that's fine. 1, 2. Oh, so there is an A here. So what's my rise? And what's my run? 1. But remember, it's run squared. So what is 1 squared? Just 1. So my A value is actually a 2. And where would I put that A? In front of the x squared. But again, we are not expecting you guys to know how to do that, all right? I show you for those of you that are curious. I hope that there are a few curious minds in here. All right. One last concept and then we're done for today, and I'll give you the practice problems. So look down here. It says, does the graph to the right have any x-intercepts?
No.
No, it does not. How do you know? Oh my gosh. The quadratic does not touch the x-axis, so no. How can we write a quadratic equation for a graph with imaginary roots? Can you look at this and say, oh, I know the imaginary roots, they're this? No, they're imaginary. Do they actually exist in real life? No, so I can't point to this and say, oh yeah, those are the roots. They don't exist really. So you would have to be given the imaginary roots. You would need to be given the imaginary roots. So this problem doesn't actually give them to you. That's why you can't look at the graph and say, oh, I know what the equation is. But what they'll do is they'll say, if the roots are x equals plus or minus 3i, find the equation. So if they do say that, you use the exact same steps as above. We take our roots and we find the what? Starts with an F. Factors. So we have one root at a positive 3i and one root at a negative 3i. What is the factor at x equals 3i? Negative x minus 3i. And what's the factor if x equals a negative 3i? X plus 3i. And then what do you think we do here to find the equation? You double distribute. X times x is x squared. X times 3i is 3ix. Negative 3i times x is negative 3ix. And negative 3i times a positive 3i is a negative 9i squared. If you're doing this correctly, should you end up with i's in your quadratic? No. No quadratic starts off with an I in it. No. So here, what happens to the middle terms? They cancel, and what do we know I squared is equivalent to? So it's x squared minus 9 times negative 1, which what does that become? So our quadratic is x squared plus 9, and we're done. All right, on your blue sheets that everyone should have picked up, these are your 4 practice problems, 4B-3. These are your 4 problems. I will put these problems on my website, yes. I'll make them darker right now so you can see them. There you go.